Hi everybody. In this video we are going to discuss superposition. Suppose we have a rather complex electronic network consisting of several voltage power supplies and a current supply and several resistors, for instance, put over here. And suppose we want to calculate the current which is flowing into this voltage supply. Well, that's a rather complex calculation when using the Kirchhoff's equations and Ohm equation and putting it all together. By using superposition, we can make life much more easier. How does it work? What we are going to do is we look to each voltage and current source one by one. So we are going to look to each separate voltage or current source. When we do that, all other voltage sources will be replaced by a short circuit and all other current sources will be replaced by open connections. Well, to get that right in your mind, you can look to the symbols of a voltage supply and a current supply and you think the circles away. For instance, when we have a voltage source over here and when we make them inactive, we are going to think this circle away, which leaves us with a short circuit over here. We can do the same thing with a current source. This is a symbol for a current source. When making this current source inactive, we can remove that circle, which leaves us with an open connection over here. Well, let's start with an example, and that is the example which is drawn over here, in which we are interested in the current Ix flowing into this 3-volt voltage source. And we are going to look one by one to each voltage source and current source. And we start with the contribution of this voltage source. So the next step will be making this voltage source inactive by replacing it by a short circuit and making this current source inactive by replacing it by an open connection. Well, let's do it. So we have the circuit over here. This current source will be replaced by an open connection and this voltage source will be replaced by a short circuit. And this is the remaining circuit diagram which we have. And we can make it much more easier because what we see is when we are interested in the current over here flowing into this 3-volt voltage source, the first thing to make life much more easier is to replace that 5 kilo ohms resistor over here because this is an open connection, so no current can flow in this path, so we can leave it out. What we also can see is that this part of the connection of the circuit, that short circuit parallel to a resistor of 4K, can be left out because also here can no current flow because there's no connection anymore to this voltage source. So this is the only part of the circuit which is left, and now we can calculate the contribution of Ix due to this voltage source. Well, we can see that due to Ohm's law we can replace this series connection by one resistor of 6K, which brings us to a current flowing out of this voltage source of 3 volt over 6K is 0.5 milliamps. But Ix1 was defined the other way around, so it brings us minus 0.5 milliamps. So minus 3 volt divided by 6K is minus 0.5 milliamps, which is the contribution, as I said, of this voltage source. Now we are going to look to the contribution of this current source. And what we're going to do is we replace this voltage source by a short circuit, and we do the same thing with this voltage source, which gives us the following situation. This is a short circuit, and this will be a short circuit, and this is the remaining circuit diagram we have. We can make life much more easier again by making some contributions which we can leave some components out. And the first thing what we can do is we leave that 4K resistance out because that 4K resistance is parallel to a short circuit of 0 ohm, and 0 ohm parallel to a resistance with a higher value means that this part can be left out because all the current will flow to that short circuit connection. Well, we are interested in the current flowing over here, and again here is 6K parallel to a short circuit of 0 ohms, and so we can leave this 2K and 4K out, and this is the remaining circuit we have. So 1 milliamp flowing in this direction, back to the current source, so the contribution of this current source due to the current which we want to know is 1 milliamps because it's flowing also over here. Now we have one part left, one voltage supply left, which is this voltage source, and we can do the same thing over again by replacing this voltage source by a short circuit and replacing this current source by an open connection. And then we have the following network. This is a short circuit, this is the open connection, and we are interested in the current flowing over here. And what you can see already is that from this voltage supply there is no current path through this connection. So we can make some assumptions by leaving some components out, like this 5K resistance, but we see immediately that there is no there's no current flowing from this voltage source into this direction, into this wire. So the current IX3 will be 0 amps. So, well, we have 3 contributions due to 3 sources, 2 voltage sources and 1 current source, and we can add them all together, and then we have minus 5 milliamps as a contribution from this voltage source, 1 milliamps as a contribution from this current source, and 0 milliamps as the contribution from this voltage source, which add up to 0.5 milliamps. So that is all about superposition, and as you have seen, that makes life much more easier in complex networks where many voltages, many voltage sources, many current sources are involved. But in several cases, in some cases I should say, you can't apply superposition. So when can't you use superposition? Well, that is in the case that resistance, capacitors or inductors which you may use in your circuit, if these parts are not constant values, if they change over time, for instance due to heating, then you can't use superposition. You can't use it either in power calculations where multiplications take place of voltages and currents. You can't use them if nonlinear components are applied, so like diodes or transistors. You can't use it if depending sources or control sources are applied, and you can't use it if the network structure changes, for instance when you switch some components on and off by using relays or switches. That's all folks, see you next time. Thank you for watching.